Alright, today we'll talk about how we find the equations for the tangent and normal lines on conics. What are these? Well, we've talked about tangent lines. Tangent lines, if you look at the green line here, it touches at one point, makes it a tangent line. Normal lines you might not be familiar with, but pretty simple. It's just perpendicular to the tangent line. Okay, so at any given point in this graph, it looks like we're talking 0, -1. At 0, -1, the green line would be the tangent line, and the yellow line would be the normal line. They meet at a 90-degree angle. Alright, we've talked in class earlier in the year how the derivative of a function will give you the slope of a tangent line at any xy point. I am tempted to use a little calculus here to show you how we derive these slope values that you see in this column over here, but I'm going to hold off just because it is beyond the scope of this class. It would take me another lesson to teach you some of the chain rule and the implicit differentiation. So we'll hold off on that, and I'm going to provide you with this handout. Okay. My goal right now is that you know how to figure out the tangent lines and the normal lines. Okay. So if we're not given this form, if we're not given the standard form of one of these conics, well, what do? Well, keep in mind, every time you're given the general form, if you complete the square, that results in the standard form. That gives you the standard form. Okay, so once you have that, you can determine what kind of shape you have. And then what are you going to do? Well, if we're finding the tangent line, the slope of the tangent line right here, what we're going to do is just pick out our variables, you know, our a squareds and b squareds, our x's and h's, and plug them in and find a value here. That'll give us the numeric value for the slope. Okay? Oh yeah, and just so there's no confusion, when I copied this picture over into this program, this XY point here didn't copy over correctly, so just so there's no confusion. Okay? Let's look at this problem here. We're going to try to find the tangent and normal lines for this equation at this given point right here, 0, -1. Well, it looks like we have a parabola. How do I know that? Well, I'm looking at this, and if you notice, there's only one term that's squared. Okay, that x is going to be squared once I FOIL that. This y is just a y to the first, and it's not going to change. We have one squared term. That's a parabola. Let's get it in standard form. Alright, well, sometimes we have to complete the square. In this case, it's partly done for us. All we really have to do is move this one y term over here. We're going to move this -8, whoops. We're going to move this -8 times y plus 3 over here. And that will, actually, that'll result in the standard form. So that would give us an x plus 4 squared. And if I move it over, it'll become positive. And just to compare, here is the standard form for the parabola. That's a y. Let me fix that. Okay, so our vertex, not that it's asking for this stuff, but we can now tell us that the vertex here is going to be -4, -3. And the whatever's in front here, that's what 4p is. So 4p in this case equals 8. Okay? P, if you divide by 4, equals 2. All right, well, not that it's asking for it, but at this point, we could graph this. If you look here, you have your vertex is at -4, -3, and your p-value is 2, so if we went up 2, that would give us the focus. If we went down 2, I don't have it on here, but that would be the directrix. And the latus rectum, if you recall, the latus rectum is this focal chord right here going through the focus. And it is 4p units long. Okay, that's where that 4p in front comes from. Okay, and if you notice right here, if your p-value is 2 units, well, there's 1p, there's 2p, 3p, 4p. Okay, there's your latus rectum. All right, let's get back to this equation now. All right, well, if we look at, let's go back here now. If we take a look at this handout here. Okay, well, what do we have? We have ourselves a parabola. We have a parabola where the x is squared. So, parabola, right here, is where your x is squared. Okay. So, right there is how we're going to figure out the slope right here. We're going to figure out the slope using this one right here. Okay, this is where your x is squared. So this one we're going to use for the slope. So that would be an x minus h over 2p. Okay. All right, let's close that. Whoops, we need that up there. So, all right, well, let's go back to our formula here and our equation and see what we got. So x minus h, well, remember, this is your xy point. So our x value is 0 minus our h value. Our h value is negative 4, so that's minus a minus 4 over 2p. 2, well, what did we say p was? P was 2, right? So 2 times 2. And this is going to give us 4 over 4, which is a slope of 1. Cool. All right, so we have a slope of 1. All right, well, how do we find the equation of this line? Now that we have the slope and we have a point, well, we can use the point-slope form. If you don't recall that one, let's move this stuff over here. The point-slope form. Let me change this color here. Y minus y1 equals m times x minus x1. Anytime you need to find the equation of a line, you can use this. All right, well, now that we have the slope of this line is 1 at this given point, 0, negative 1. So we have y minus a minus 1 equals, that's an equal sign, our slope is 1, and it's x minus our x value. In this case, it's 0. All right, that gives us a y plus 1 equals x. And if you subtract 1, you get your slope-intercept form, which is y equals x minus 1. Not that it was asking for the slope-intercept form. You could have easily left it in this form or this form, and that's totally acceptable. But now we can graph it. But it's also asking us for the normal line. All right, so fine. We have, let me make this smaller. So right there, this is the equation for the tangent line. How do we find the equation for the normal line? Well, I said earlier that the two lines are perpendicular with one another. Okay? So if you look over here, if this slope is 1, and that's perpendicular, what do you remember from geometry? Perpendicular lines have negative reciprocal slopes. So the negative reciprocal of, well, this right here was 1, right? So that if that's a 1 over 1, the negative reciprocal would be negative 1 over 1, which is just negative 1. So the normal line is going to have a slope of negative 1. All right, well, let's go back and do the normal line now. So this is for the normal line. Y minus y1 equals m times x minus x1. And, well, the slope for that's going to be negative 1. And you know what? The tangent and the normal go through the same point. They both go through 0, negative 1, so let's use the same point. That's what's supposed to be a minus there. So that's going to be a y minus a minus 1 again. And that's going to be an x minus a 0 again. And that's going to give us y plus 1 equals, that's an equal sign there, a negative x. And we have negative x minus 1. Okay? And if you look at the graph, yeah, let's do this. Okay. This right here is the parabola, and the point we were talking about is 0, negative 1, 0, negative 1. Okay. Right there is the equation of the tangent line, which we said was x minus 1. There's my y-intercept, and I have a slope of 1. And right here is the normal line, negative x minus 1. Okay, so again, it goes through negative 1, and it has a slope of negative 1. What you're going to do now is you're going to pause the video after I bring up these steps, and you're going to find the equation of the tangent and normal lines for this conic right here. We'll check your answers after you're done. But first, you're going to complete the square. After that, identify what conic you have. Then look at the tangent line slope formula from the handout. This handout over here, okay? Plug in what you need to determine the slope values for the tangent and normal lines. Don't forget negative reciprocal. Then plug the given point, and right here's the given point, and these slope values into the point slope form to get your equations. Do that now, and we'll check your answers in a minute. Alright, let's see what happened now. Let's complete the square here. We're going to get our x terms together, and we'll get our y terms together. And we're going to complete, oh, that's a y plus something. And we're going to move that constant over, have a 457 over on the right. Whatever we need to take out to make this a 1x squared for the x's, take out. And same thing over here. For that y squared, make that a 1y squared for the y's. So we're going to take out a 32 here, which will give us x squared minus 4x plus something. And when we take a negative 9 out, we have a 1y squared, a negative 2y, and something, and 457. Alright, that 32 is still a factor in front, but we're going to complete the square. Half of negative 4 is negative 2, that goes there. We've done that before. Square it, you get a positive 4, that goes there. Over here, negative 9, we have y. Let's take half of negative 2 is negative 1. Square it, you get a positive 1. Now, we didn't just add 4 and 1. Remember, there's a 32 out here we distribute. We really added 32 times 4 and negative 9 times 1. 32 times 4 is 128, and negative 9 times 1 is negative 9. After you add up those three values, you get 576. Now, if you notice, all the standard forms are set equal to 1. So how do we make 576 1? We divide by itself. Whatever you do to one thing, do to all. Okay. Now what happens here is 32 over 576 reduces to 1 over 18. And 9 over this reduces to 1 over 64. And of course this is 1, which gives us our standard form of the equation as x minus 2 squared over 18 minus y minus 1 squared over 64 equals 1. We have a hyperbola. We have a hyperbola with the x term as the positive fraction. So, referring to this, we have a hyperbola where the x is positive. We're going to use this slope formula right there. Let me write it down here. We have b squared x minus h, a squared, y minus k. Okay, so let's make that smaller, and let's figure out our slope formula here, or slope value. Our b squared is 64, and our a squared is 18. Don't forget where our x and y values are. Alright, they're up here. Let me rewrite them up here. Negative 4 comma negative 7. So our x value is negative 4, and our y value is negative 7. Our h value is 2, so subtract 2, and our y value is, k value is 1, so subtract 1. After you do the math here, this slope simplifies to 8 over 3. That's the slope of the tangent line. So, let's get rid of that. The tangent line equation looks like this. Y minus y1 is your point slope form, equals m times x minus x1 is your point slope form. We have a y minus a minus 7. We have an x minus a minus 4. The slope we just figured out is 8/3. Okay? That's the equation of the tangent line. You can get it into point slope-intercept form if you want, but it didn't specify, so that would be acceptable right there. I'll just move that up. All right, now for the normal line. Well, for the normal line, the only difference is our slope is going to be negative 3 over 8. It's going to be the negative reciprocal of 8/3. Okay, so negative reciprocal. But it's going through the same point. It's still going through negative 4, negative 7, so let's use the same points. Okay, and again, there's point slope form. You can get it into slope intercept form, but it didn't specify. That would be sufficient. If it did tell you to graph, what you might want to do is then get them into slope intercept form, which would make them graph a little bit easier there. Okay, let me just do this. And that's what it would look like right there. That's the hyperbola we just found. Okay, and that's the point -4, -7 right there. Let's make that even bigger here. Okay, so right there is -4, -7, and there are the two lines that we just found. All right, let's see what we got. We worked on day 10 here, tangents and normal lines. All right, so coming class, ready to work on. We're going to do 4 problems in class. Okay, I'll see you then.